You are listening along with the 3.3 version 1 reading. Before you read, take a look at the text features. We have the bolded headings, plate boundaries, divergent plate boundaries, transform plate boundaries, convergent plate boundaries, and a little bit about plate motion and convection currents, which will be review. You will see some italics with the definitions of the words. Okay, and there's no diagrams in here, but if you need to look up some diagrams, you can, or you might even draw some while we read. Let's begin. Plate boundaries. Imagine placing two books side by side. Imagine that each book is a tectonic plate. The place where the edges of the books meet represents a plate boundary. How many ways can you move the books along a set of boundaries? You can pull the books away from each other. You can push the books together. You can slide the books past each other. Earth's tectonic plates move in much the same way as you can move these books. Divergent plate boundaries. A divergent plate boundary forms where two tectonic plates separate. I'm going to put a star there so I know to go back because that's the definition. Divergent means moving apart. Moving apart looks like this. Moving apart, going away. Mid-ocean ridges are located along divergent plate boundaries. That's one type of landform. When the seafloor spreads at a mid-ocean ridge, lava erupts. As the lava cools and hardens, it forms new oceanic crust. As this process continues, the plates move away from each other. Divergent plate boundaries can also exist in the middle of a continent. At these boundaries, continents pull apart and a rift valley forms. The East African Rift is one example of a continental rift. You can pause here to fill out your notes or listen to the whole reading and then go back and fill out the notes after. Transform plate boundaries. The San Andreas Fault in California is a transform plate boundary, so it might form fault lines. A transform plate boundary forms where two tectonic plates slide past each other. That's the definition, and sliding past looks like this. As they move past each other, the plates might get stuck and stop moving. Stress builds up where the plates are stuck. When the stress is too great, the rocks break and suddenly move apart. The result is a rapid release of energy in the form of an earthquake. So transform plate boundaries are most responsible for earthquakes. Convergent plate boundaries. A convergent plate boundary forms where two plates collide. The denser plate sinks below the more buoyant plate. More buoyant is another way of saying less dense. In a process called subduction. A subduction zone is the area where a denser plate descends or goes down into Earth along a convergent plate boundary. The two types of convergent plate boundaries are ocean to continent and continent to continent. And just as a quick illustration, convergent looks like this, where they come together. Ocean to continent boundary. When a dense oceanic plate and a less dense continental plate collide, the oceanic plate subducts or sinks under the edge of the continental plate. So we have oceanic and continental. So the continental stays on top, the oceanic plate sinks. This creates a deep ocean trench and a line of volcanoes forms on the edge of the continent. So you might get volcanoes along here, but down here where there's kind of this boundary, you can get a deep ocean trench where the ocean gets very, very deep. This process can also occur when two oceanic plates collide. An older and denser oceanic plate will subduct beneath a younger oceanic plate. A deep ocean trench forms along with a line of volcanoes. Over to the next page to finish off our convergent plate boundaries. And I know that it's still convergent because this is that smaller bolded text, so it's a subheading. At a continent-to-continent boundary, convergent plate boundaries also form when two continental plates collide. When this happens, neither plate is subducted. The less dense plate folds and deforms, forming mountains, such as the Himalayas in India. So you have them coming together, and the less dense plate, it will fold, and we have something called uplift, which creates mountains. Okay. Lastly, plate motion. You learned that the main objection to Wegener's continental drift hypothesis was that he could not explain how or why Earth's continents move. Scientists now understand that continents move because the asthenosphere moves underneath the rigid lithosphere. And both of these include or are parts of the mantle. Convection currents. The circulation of material caused by differences in temperature and density is called convection. That's when we get that circular motion that you remember. For example, the upstairs floors of homes are often warmer because hot air rises. Hot air is less dense than cold air. As the cold air sinks, the hot air rises. That is all review. You remember this. Convection in the mantle is related to plate tectonic activity. The warmth for convection comes from radioactive elements inside Earth, such as uranium, thorium, and potassium. When materials such as solid rock are heated, they expand and become less dense. Remember, the hotter they are, the farther apart the material gets. They expand. Heated mantle material rises and comes in contact with Earth's crust. Thermal energy is transferred from hot mantle material to the colder surface above. As the mantle cools, it becomes denser and sinks, forming a convection current. These currents in the asthenosphere act like a conveyor belt, moving the lithosphere above it. Therefore, tectonic plates move in response to the heating and cooling of mantle material. And that review of convection currents as to why we have the plates moving is the cause for these different plate boundaries, divergent, transform, and convergent, depending where you are on Earth. Make sure you complete the guided notes